So in this example, we're going to be comparing two different plans to rent a car and figuring out which one's going to be the best, depending on the number of miles you're going to drive this car. So in Plan A, we have a cost that's going to be represented. I'm going to call it cost of Plan A. It's going to be $40 per day, so $40 multiplied by the number of days, plus we have 17 cents, which I'm going to convert to dollars, so $0.17 multiplied by the number of miles. We have a second option, which is cost of Plan B, which would be a flat $60 per day. So $60 multiplied by the number of days. But in this case, we don't have any per mile charge. It's unlimited free miles. All right, so these are kind of the two different representations we have going on here. I'm going to go ahead and say M is our number of miles. And in our case, what we're trying to do is figure out if you rent this for 1 day, what's the range of miles that Plan B is going to save you or be the better deal. Okay, so we have 1 is our number of days. All right, so we can represent cost of A is going to be $40 multiplied by the number of days plus 17 cents, 0.17 multiplied by M because I'm using M for miles. Or we could say this is 40 plus 0.17 M. Whereas cost of Plan B is going to be 60 multiplied by 1, or a constant $60 for the entirety of your 1 day rental, not dependent on miles. So let's think about what's going on as we sort of visualize this on a graph. I think that helps out a lot of times when we're looking at these. This is going to be a function depending on the number of miles, so that's going to go along kind of the x-axis, and then our cost is going to be along the y-axis. Our one plan, Plan B, is going to cost us $60 no matter how many miles we drive. So it's a constant function going straight across left to right. Whereas our other function is going to start out and it's going to be $40 if we didn't drive it any miles, but that's going to increase over time at a constant rate of 0.17 multiplied by however many miles you drive it. So that's part A. So as you can see, if we start with 0 miles at the beginning, B is going to be more expensive, that plan. However, at some point along the way, there's going to be a place where we cross, or they're actually equal, and then it changes and B is lower on the cost side, up and down, than where A is. So our goal in this is to figure out exactly what is that number of miles M where these two graphs basically cross. So what we want to do is we want to set these equal to one another. So our representations, I'm going to go ahead and say 40 plus 0.17, the cost for A, is going to equal the cost for B, 60. And all we have to do is we have to solve this down for M. That's going to give us that ideal place where these basically cross, or they switch places and A becomes more expensive than B. So to solve this down, what we want to do is we want to isolate M eventually. To do so, let's go ahead and subtract the 40 from both sides. This is a linear equation that we're solving down. 40 minus 40 is going to go away as we combine like terms. 0.17 M is going to be 60 minus 40 makes 20. And then to get M all by itself, well, M is multiplied by 0.17, so we're going to have to divide by 0.17 on both sides to get it all by itself. So as we do this, M will be isolated on the left-hand side, and I got this to be 117.647 approximately. So I'm going to go ahead and approximate that to the nearest mile to be 118 miles. So the range, that's what we're looking for, right? For what range of miles will Plan B save you money for the 1 day rental? It's everything to the right of 118. So I'm going to go ahead and represent that as 118 miles included, and anything you drive beyond that, so up to an infinite number of miles over to the right, we never include infinity. So this would probably be how I'd represent it using interval notation. Hope this makes sense and helps out as you're working with mathematical modeling and real life problems trying to figure out the best answer. Good luck.